Okay, so let's talk about the different kinds of operands first. So there are three main kinds of operands. So the first kind is an immediate operand. So an immediate operand is a value that is just encoded in the instruction itself. And so you have to take the value and embed it in the instruction embedding, which increases the size of the instruction, right, by the width of the value. In our form of assembly, we're going to write this using the $ as a prefix. So for instance, this is an immediate operand with value 42. We can also write these using hexadecimal. So this is an immediate operand with value hex 1, 2, 3, 4. So the second type of operands are registers. So if a register operand, is stored in the register file. So there are a bunch of different registers, and we access each of those registers via a register number. But in assembly, we don't use the numbers directly. We have names for all of the registers, and we'll see. So here are some names. So EAX and RSP are names of registers, and we'll see more names of registers here in a second. The third type of operand is our memory operands, and these are operands that are stored out in main memory, and we access these via their address, as you might imagine. And so sometimes we'll use just the raw fixed address, but more often we'll access these things by calculating an effective address based on the value of a register, or doing some sort of arithmetic operation in order to find the location in memory that we want to access. And so the effective address of a memory operand is the place in memory, the actual final address that we're accessing, which may not itself be directly encoded in the instruction. The instruction just contains enough information so that the CPU can calculate the effective address once the program is running. And there are a bunch of ways of writing this, and all the different ways are referred to as addressing modes. Okay, so let's dive a little deeper into register and memory operands. So there are a variety of register operands in x86 64. Some of the ones that we will focus on for now are the general purpose registers. So RAX, RBX, RCX, RDX, and then RSI and RDI. And so you can envision these as a bunch of different slots in the register file of the computer. Some of these names have legacy meanings. So for instance, our AX used to be the accumulator register. These meanings are less important for us now, and we're just going to think about these as general purpose registers that we can use for whatever purpose, for whatever reason we want. And then there are also some special purpose registers. So there is the instruction pointer, or RIP. There's the status info register called flags. In your textbook, these are called condition codes. And then there are base and stack pointers that we will, and we'll talk more about these in later days. So these are the main ones that we'll focus on for now, although we'll learn later that there are actually more registers than these. Okay, so in terms of memory operands, as I mentioned before, there are a lot of different ways of calculating an effective address for a memory operand. So the simplest is just an absolute memory address. And so if you just see a memory address encoded in assembly, that just means that we have hard-coded the memory address. And so the effective address is just that address. This is actually remarkably rare, and that's because things tend to move around in memory, and they're loaded into places in memory that change every time you run. And so this is actually not used all that often. So there are also some indirect addressing modes. So there's the straight up indirect addressing mode, where you give it a register and you put that register name inside of parentheses, and that indicates that that it is a memory address, or a memory operand rather than a register operand. And the effective address is just the value of the register. So you can think about this a little bit like dereferencing a pointer. So the register is going to be storing the address of some place in memory that we want to get to. In order to get to it, we kind of need to dereference that pointer. And that's what the indirect memory addressing mode allows us to do. By putting the parentheses around the register name, we say we don't want to use the value of the register. We want to use the value of the register as an address and go get the value that is located in memory at that address. We can also add a fixed displacement to the value of that register, and that's the base plus displacement addressing mode. Very similar, except that we now have a fixed offset that we write outside of the parentheses on the left-hand side, and we take that fixed offset and we add it to the value of register at runtime, and that's going to be the effective address. There are also a couple more complicated addressing modes that we're not going to spend a ton of time on right now. They'll be more useful once we start working with arrays. But there is indexed addressing mode and scaled indexed addressing mode. And both of these have the potential for using two register values, which are added together, and optionally one of them can be scaled by a particular constant number. As you can see there, it's the first four multiples of 2. So we'll return to some of these things as they become useful, but for now I just wanted to give you an overview of what all of these operands look like, and now we'll start looking at the opcodes themselves.